Hello, I am Ange Delgado, and I am presenting the results of the Active SDL task, which was run under the CVPR-20 Activity Net Workshop. This is a collaboration with IARPA and Kitware. Active SDL stands for Activities and Extended Video Sequester Data Leaderboard. The other members of NIST include John Fiskus, Young Lee, Axel Godil, Lucas Didich, Elliot Goddard, Baptiste Tricot, Jesse Zhang, and Jim Golden. Here is our standard disclaimer. Here is a brief outline of the talk. We'll start with a brief overview. Active is an evaluation series that we've been working on since 2017. It is meant to accelerate the development of robust multi-camera automatic activity detection algorithms for forensic and real-time alerting applications. Here are some video examples that show some of the activities that we are currently using for the Active SDL task. The main goal of Active is to advance the technology that automatically detects a target activity and identifies the objects associated with the activity. This project is a partnership between NIST, IARPA, and Kitware, and this slide shows the relationship. Here we can see the progress of the evaluations and datasets over the years. Each year, we increase the level of complexity of datasets. For example, more videos, more activities using known and surprise activities, and known and unknown facilities in which the activities occurred. Now onto the Active SDL evaluation. We have two different types of evaluations, self-reported and independent. For self-reported evaluations, the performers run their software on their hardware and submit the system output to the NIST scoring server. For the independent evaluation, the performers submit their runnable system to NIST. NIST then runs the system on the sequestered data using NIST hardware, and we post the results on the leaderboard. Doing a sequestered data evaluation allows participants to use the same hardware for the runs, gives us the ability to protect sensitive data, and we are able to reproduce results from the submitted systems. We have found some disadvantages as well. We've seen some participants have difficulty with configuring their systems to work on the NIST infrastructure. This is easily managed by working with the teams and providing data to assist in solving any errors that occur. Now we move on to tasks and measures. The task being evaluated is the activity detection task. This is testing if the system can detect the presence of a specified activity and localize it across the video sequence. The system output includes the start and end frames indicating the temporal location of the target activity, and the presence confidence score indicates how confident the activity occurred in that time frame. The primary metric being used to evaluate systems is the normalized partial area under the net curve. The other reported metrics are real-time speed factor and time limit scoring, reported for systems slower than real-time. And now onto the datasets. The SDL evaluation dataset is based on MAVA Multi-View Extended Video with Activities dataset, which was collected by Kitware. This consists of synchronized multi-camera videos that include indoor and outdoor scenes with EO and IR sensors. This is collected for IARPA for the DIVA program and freely available. Here are the 37 activities for the MAVA Test 3. The activities could be broadly categorized as person activity, person-object interaction, vehicle activity, and person-vehicle interaction. Here we are showing a montage of randomly selected known facility videos. And now on to the results. This table shows Active 20 SDL participants ranking. We had a total of 40 submissions from 10 organizations and from 2 different countries. This table describes the teams and their NADC results that are the best system per team. Our highest performance on activity detection was UCF with NADC of 37%, followed by INF with 39%. Here we show the ranking of system performance across the 37 activities. The x-axis represents the 10 teams, and the y-axis is the NADC metric. The black points indicate the mean value for each team, and the green arrow bar indicates the standard deviation. The orange dots show the values of the 37 different activities. Here we show the ranking of the teams on the relative runtime. The x-axis shows the 10 teams, and the y-axis is the relative processing time. This shows that only 3 teams are slower than real time: JHU, VUS, and the combined UMD and UCF system. This figure shows the system performance by submission days for all the teams. The x-axis shows the submission days since our evaluation on July 1st, 2019, and the y-axis shows the mean partial ADC. It shows that there's a large improvement in system performance over time from the start of the active SDL, which was based on NAVA Test 2, compared to active SDL-20, which is based on NAVA Test 3. We can see our top performing team started at around 0.9 with their first submission and worked their way up throughout the days to get them to the top spot. This plot shows the ranking of activities across the systems. The x-axis is the activity type and the y-axis is the performance metric. The point marked in black indicates a mean value across different systems, and the green arrow bar indicates a standard deviation. The orange dots show the values of the 10 systems. In this plot, we show activities that are easier or difficult to detect for each team and for the average. The x-axis shows the team names and the average activity ranking. The y-axis shows the 37 activities. We can see that almost all systems found that person abandoned package to be the hardest activity to detect. We observed a remarkable performance improvement across the systems, and we invite the top 3 teams, UCF, CMU, and VUS, to present their findings. And now on to our next steps. The evaluations are still ongoing. The SDL and TRECVID evaluations are supported through 2022. Thank you for your time. Are there any questions?